Supermassive black holes have a reputation for consuming everything in their path, from gas clouds to entire solar systems. So, is there any way aliens could live on a world that actually orbited one of these cosmic beasts? Today, we will discuss with you about, is it possible for a habitable planet to revolve around a black hole? Welcome back. This is Ignatius Life. Surprisingly, the answer is a tentative yes. Researchers say, although there are plenty of reasons why life could never take hold in such a place, if it did, living on such a planet would be truly surreal, with the black hole filling nearly half the sky and concentrating leftover photons from the Big Bang into a pseudo-sun. The study was inspired by the 2014 film Interstellar, in which astronauts travel through a wormhole to a giant black hole and visit several planets in orbit around it. For life to evolve, a planet needs a source of usable energy and a sink for unusable waste heat. It's the difference between the two that drives the processes that create life. In Interstellar, the situation is reversed. The sun is cold and space is hot. The black hole itself is an ideal heat sink. The researchers argue unusable energy can come from the cosmic microwave background, weak radiation from the Big Bang that permeates space. At just a few degrees above absolute zero, the CMP is weak, but the extreme gravity of a supermassive black hole would scrunch the radiation into optical wavelengths and funnel it into a narrow beam. On one of these bizarre planets, the researchers say the CMB would appear as a bright star just on the edge of the black hole's shadow. In order to receive strong enough CMB light, a planet would need to orbit very close to the black hole's event horizon. Normally, an object that close would soon get sucked in if the black hole is spinning fast. However, close stable orbits are possible. For a planet to get close enough, the surface of the black hole would have to spin at less than 100 millionth of a percent shy of the speed of light. The black hole would also need to be large. The team calculates at least 163 million times of the sun's mass. That's because smaller supermassive black holes like the one in our Milky Way, weighing in at 4 million solar masses, tend to rip stars or planets apart with tidal forces as they approach. Around larger black holes, tidal disruption doesn't happen until a star or planet is inside the event horizon, so anything outside is safe from that fate. For an orbiting planet to thrive, the galactic center would also need to be tranquil, an old galaxy, almost empty space surrounding the black hole. That's because any other stray matter being sucked into the black hole would emit a blast of radiation during its death, spiral powerful enough to kill any life on a nearby planet. It would certainly be no place like home. The deep blackness of the event horizon, looming over nearly half the sky, would be a forbidding presence. And because of the time dilation effects in Albert Einstein's theory of gravity, known as general relativity, 1 year passing on such a planet would see thousands of years go by around an ordinary star. Even if life could take hold on such a world, there's little chance of detecting it. A planet passing in front of a black hole isn't going to make it appear any dimmer when it's black already. How can you find it? A vast array of radio telescopes like the one used last year to image a black hole for the first time might be able to detect such a transit. Technically, it's not so easy, but in theory, it's possible. Another problem is getting a planet there. Some scientists posted that planets could form in the cold disk of gas and dust that exists at some distance around the galactic center. But it's difficult to imagine a way to move the planets to orbits skimming barely above the black hole's surface. Perhaps most significantly, most stars in the inner parts of galaxies would likely be stripped of their atmospheres by the powerful blasts of extreme ultraviolet light produced by the central black hole as it grows by gulping gas and dust. A planet close to its surface wouldn't stand a chance. Astronomers can see large, bright suns, known as S-type stars, swooping in close, but some scientists think that older and dimmer objects such as neutron stars could through a quirk of gravitation, make their presence known.